Hi students, now we'll talk about very important person in physics, which is Newton. Okay, we know that the second law of Newton is F, or summation of external forces, is equal to mass multiplied by the acceleration as a vector quantity. Now we can find this formula from momentum formulas. we know that the initial value, if they have any change in momentum, the initial value is mass multiplied by the initial value of the velocity. This is if we need to take it as a vectors, it's okay. Also, if we need to take them as scalars, it's okay. The final momentum value is also equal to mass multiplied by the final velocity. If we take that change in momentum, we know that from the previous examples that the change in momentum is equal to the mass multiplied by the change in velocity, m v final minus v initial, which is m delta v. Okay, if this change in momentum happened in a period of time, we need to find this rate of change. We need to divide on time. So delta p over delta t, we need to divide over time all the terms. This is equal to change momentum m delta v over delta t. This, when we order them, the terms, we can find that it is equal to the mass, which is constant with respect to time, multiplied by delta v over delta t. What is this value, delta v over delta t? We know that it is the acceleration. Okay, so the change in momentum with respect to time is equal to the mass multiplied by the acceleration. This is the force, the external forces on that body. Okay, so this is Newton's second law. This side of the formula, m multiplied by a is equal to F. This is Newton's second law, and this is equal to change in momentum over delta t. So there is a relation between the forces and the change in momentum on that body. As a vector quantity, the change in the forces, the external forces, is equal to m multiplied by the acceleration vector, which is equal to the change in momentum vector divided by the change in time. This is the relation between the change in momentum with respect to time and the forces. Okay, let us get back to the previous example when we compute the change. This one, when we compute the change in momentum for a moving body, 3 kilograms, the mass is 3 kilograms, the initial velocity is 3, the final velocity is 1 in positive x direction. When we find that the change in momentum was minus 6, if you remember, assume that this process takes 10 seconds. Okay, what is the force acting on this body? What is the acceleration? You will see that we have logical ideas. If the body gets slower and it was fast, what happened to get it slower? What is the force that gets the body slower? It is the friction force, if you remember. Okay, now let us compute what we need to compute the force. For example, at first, the force is equal to delta p over delta t, as we see here. Delta p is minus 6, as we compute before. Delta t is 10. Then we have negative sign. The force will be minus 0.6 in newtons in x direction. In this direction, it is an opposite sign of our motion, of the motion of this body. What is this force? What is the negative force? It is a friction force. Okay, Okay, what if we need to compute the acceleration? The acceleration from Newton's second law, it is the force divided by the mass. The force is negative 0.6, the mass is 3 kilograms as we see here. The acceleration is negative 0.2 meters per squared second in x direction, in negative x direction. Okay, this is the relation between the momentum and the Newton's second law. It is simple. Thank you.